Hello and welcome to part 2 of lesson number 4 in Unit 1 Linear Systems in our grade 10 academic math class. This is solving linear systems of equations using substitution. So since this is part 2, we've already learned how to do substitution, and just as a recap, we are taking an equivalent value from the first equation and substituting it into the second equation with the goal of having only one variable left that we can then solve. Once we've solved for the first variable, we substitute back into one of the first two equations to get the second half of our answer. We do a check using the other original equation, get a therefore statement on it, and call it a day. We did one here graphically and then followed it up by doing it by substitution and found the same answer, which is great. We did one example over here. Now let's get to another example. So we have 3x plus y equals -5 and 4x plus 5y equals 18. So with the goal of isolating one of our variables, this is the one that pops out at me right here. Since we already have a variable with a coefficient of 1, I'm just going to rearrange number 1, and I'm going to do that by transposing 3x over to the other side by subtracting 3x from both sides. So I then have my new equation is y equals -3x minus 5. That's equation number 3. And we have a y value being equal to something else. And we are going to substitute that in for the y in the second equation. So let's get that going. We're going to substitute 3 into number 2. So I'm just going to write this out, 4x plus 5. Now instead of y, I'm going to write in an equivalent value for y from the first equation, which is -3x minus 5 equals 18. Now we do a little bit of an expansion here. We have this 5 to multiply by -3x and -5, so that's going to give us 4x minus 15x minus 25 equals 18. Let's simplify a little bit. 4 minus 15 gives us -11x's minus 25 equals 18. We are going to transpose -25 to the other side by adding 25 to both sides. We then have -11x's equal to 43. And we isolate x by dividing both sides by -11. Yikes, giving us x equals -43/11. And again, I just moved the negative out of the denominator and sort of assigned it to the whole fraction. Now, some of you might get to this point and think, my gosh, I must have made a mistake in here somewhere. Sometimes you do that. In math class, we have a tendency of kind of making the numbers work out nicely. There's nothing inherently wrong with this answer. It's as good a number as anything else. And I don't think we made a mistake, so let's just keep pressing forward. So which of these two equations looks like the easiest to substitute into for x? I don't know that there's one that's easier than the other, so maybe we'll just do the first one. So we are going to sub x equals -43/11 into number 1. All right, so number 1 was 3x plus y. 3x plus y equals -5. And now we're going to do that substitution. So we have 3, and I'm just going to cheat and put that over 1. -43/11 plus y equals -5. So let's do a little bit of multiplication. There's no reducing we can do here, so 3 3s are 9 and 3 4s are 12. So that's -129/11 plus y equals -5. Let's transpose this guy over here, this -129/11. We are going to add 129/11. That's going to give us y equal to, let's get ourselves a common denominator here, so we have -55/11 plus 129/11. That is pretty disgusting. So we have -55, and we are going to add 129 to that. That gives us 74/11. 74/11. All right, so we're looking good. We have found an x, we have found a y. Now we are going to do our check. Now because we used number 1 here to find our y value, we are going to check using number 2. Check in number 2. So number 2 is 4x plus 5y, so that's our left side. Oh man, I'm going to run out of space. I'll see if I can fit it in. Left side, 4x plus 5y, and the right side, of course, is, I think it was negative 18. Is that what it was up there? Oh, I'm sorry, just positive 18. Just a regular old 18. Well, okay, let's do our substitution here. So we had 4 over 1 times our x value was negative 43 elevenths. Negative 43 elevenths plus 5 over 1 times 74 elevenths. Oh man, okay, we're really going to do some math here. So we are going to have, that's 1217, so that's negative 172 elevenths plus 5 fours are 20, that's 370, I think, elevenths. And now we're going to put it all together and see what we get. And man, I sure hope it comes out to something nice. So we have 172, that's negative, plus 370, and that's going to give us 198 over 11, which I'm really hoping comes out to be 18. Oh, and it is, thank goodness. Equals 18. That's awesome. Therefore, left side equals right side. And a very relieved, happy face that we were able to get to the right answer. And now we sum it up with a therefore statement. So therefore, the solution is negative 43 elevenths and 74 elevenths. Let me just make sure I got those in the right order. And I do. Looks great. So there we go. That is our second worked example. I'm going to stop the video here, then we're going to do a word problem, and then we're going to call it a day on this, and you can get to practicing. So we'll see you in a bit.